Hello everybody. This is the first video of a series going through elementary calculus of one variable all the way through multiple variables. Before we go into this series, I think it would be useful to take a diagnostic test to gauge the preparation for this series. And in order to begin learning calculus, there has to be some mastery of elements from algebra, geometry, and trigonometry, to name a few subjects. So to begin with, we'll be looking at some concepts from basic algebra in some detail, and I'll just be going through some problems. And if you're finding that you're able to follow along and solve these problems on your own, or that what I'm saying is making sense to you, then that's an indication that you are ready to begin this series. So to start, let's look at evaluating certain expressions. For example, if I were to give you -3/4, and I asked you to evaluate this expression, what you should be able to do is you should be able to tell me, well, -3 is equal to -1 times 3, and this is all to the 4th power. And we know that this should be equal to -1 to the 4th times 3 to the 4th power, because you have the product of two numbers here to some power. In this case, it's 4. And from algebra, we know that we can split this product up into the product of two powers. And from here, we have -1 to the 4th, which is equal to 1, because it's -1 to a positive power, to an even power, because 4 is an even number. So here, this is equal to 1. And then we see that 3 to the 4th power is equal, or this expression here should be equal to 1 times 3 to the 4th, or just 3 to the 4th. And then from here you should be able to say, well, I know 3 to the 4th is equal to 3 squared, and 3 squared is equal to 9. So 9, this should be equal to 9 squared, which is equal to 81. So you should be able to see that -3 to the 4th power is equal to 81. Next, let's look at a slightly different problem, which is, let's look at what if we have -3 to the 4th power. Notice the difference here. Before we had parentheses, whereas now we do not. So we're not able to do what we did before, which is split up -3 into the product of 3 times -1, and then raise that to the 4th power. So here, this is really equal to -1 times 3 to the 4th power. Well, what we found before was that 3 to the 4th power up here is equal to 81. So this -3 to the 4th power should be equal to -1 times 81, which is equal to -81. So we notice the difference between having parentheses and not having parentheses when it comes to exponents. Moving on, we can also look at what if now we have a negative exponent. So what if we have 3 to the -4th power? Well, 3 to the negative fourth power can be rewritten as 3 to the fourth power to the negative first power. And again, that's simply because whenever you have two exponents, here our two exponents are 4 and negative 1, you multiply them together. So here, the true exponent is negative 4, and negative 4 can be decomposed into 4 times negative 1. So, as we had done above, we know that 3 to the fourth power is equal to 81. So this is equal to 81 to the negative first power. But the negative first power just turns a number into its reciprocal. So we know that 81 is the same as 81 over 1, or 81 divided by 1. And the reciprocal, which is what negative 1 gives you, would be equal to 1 over 81. So 3 to the negative fourth power is equal to 1 over 81. Next, suppose you're given the following fraction. Suppose you're given 5 to the 23rd power over 5 to the 21st power. Well, we first notice that the two numbers inside of the exponents are both 5. So, a rule that you should remember from algebra is that this can be simplified as 5 to the 23rd power times 5 to the negative 21 power. But because these have the same base number, 5, this can be rewritten as 5 to the 23rd minus 21 power. Here, we know that 23 minus 21 is equal to 2. So, this should be equal to 5 to the second power, or 5 squared, which is equal to 5 times 5, which is 25. So, 5 to the 23 over 5 to the 21 is equal to 25. Moving forward, suppose I ask you to evaluate the following fraction. I give you 2 over 3 to the negative second power. Well, again, for all exponents, we can rewrite this as 2 over 3, and then we can find some expansion of negative 2. What I mean by that is negative 2 is equal to negative 1 times 2. So we can write this as 2 over 3 squared, and all of that raised to the negative 1 power. Alternatively, you can also write this as 2 over 3 to the negative 1 power, all squared. The order doesn't matter here, because negative 2 is equal to negative 1 times 2, which is equal to 2 times negative 1. The order doesn't matter. Regardless, this is equal to, well, inside of the square here, we have 2 over 3 to the negative 1 power. The negative 1 power finds the reciprocal of a fraction. So this would be 3 over 2, because the reciprocal simply means you swap the numerator and the denominator. And we raise that to the second power. For fractions, raising a number to the second power means you square the numerator and you square the denominator. So here, this fraction would be equal to 3 squared over 2 squared, which is equal to 9 over 4. So we find that 2 over 3 to the negative 2 power is equal to 9 over 4. Next, if I give you 16 to the negative 3 over 4, you should be able to say this is equal to, as we found before, we know that negative 3 over 4 is equal to negative 1 times 3 over 4, which is equal to negative 1 times 3 times 1 over 4. And what I did here was I simply expanded 3 over 4 as 3 times 1 over 4. Okay. Next, expanding that out, we have that 16 to the negative 3 over 4 is equal to 16 to the 1/4 power to the third power to the negative 1 power. And here, we take this one step at a time. So, we first evaluate what is 16 to the 1/4 power. Well, that would be 2. So we have 2 to the 3 to the negative 1. And the reason that it's 2 is because 2, well, what I claimed was 16 to the 1/4 power is equal to 2. So that means 2 to the 4th power is equal to 16. Which is true because if you expand the left-hand side, that's 2 times 2 times 2 times 2, which is equal to 4 times 4, which is equal to 16. Then we have what's next, which is 2 to the 3rd power, which is 8. So this should be 8 to the negative 1st power, which is equal to 1 over 8. So what you should find is that 16 to the negative 3 over 4 is equal to 1 over 8. Okay, we can next move to simplifying some expressions, which we were already doing above, but there should be enough practice so that you feel confident moving into this series. So next, we want to simplify the following. Given square root of 200 minus the square root of 32, I ask you to simplify this. So, as is the case with all radicals, which is what this is, the square root is just a radical, we factor 200 into two numbers. For us, it could be 100 and 2, because 100 times 2 is equal to 200. Similarly, 32 can be factored into 16 and 2, because 16 times 2 is equal to 32. So this expression is just equal to square root of 100 times 2 minus the square root of 16 times 2. Next, we can write these radicals as square root of 100 times the square root of 2 minus the square root of 16 times the square root of 2. And that's just because you have multiplication inside of the square root. That's the same thing as taking the square root of both numbers and multiplying it together. Then we next take the square roots themselves. So here, the square root of 100 is equal to 10, and the square root of 16 is 4. So this becomes 10 square root 2 minus 4 square root 2. And finally, we have 10 minus 4 square root 2, because each of these terms above have a square root 2 in them, so I factor it out here, and I'm left with the coefficients in front of the square root 2, which is 10 and 4. And then I do the subtraction, and this becomes 6 square root 2. So the square root of 200 minus the square root of 32 is equal to 6 times the square root of 2. Next, simplify the following expression. 3 times a cubed times b cubed times 4ab squared squared. Well, from PEMDAS, you know we want to deal with the exponent first. So this expression is the same as 3a cubed b cubed times this whole quantity here squared. So that would mean it is 16, because it's 4 times 4, times a squared times b squared squared. But that's just equal to b to the 4th power. So, rearranging this, we multiply the numbers together, so it's 16 times 3, which is 48. And then we have a cubed times a squared. Those are given by a cubed and a squared here. And then we take the b cubed and the b to the 4th power here. So it would be times b cubed times b to the 4th, which can finally be written as 48 times a to the 5th times b to the 7th power. The reason we get these exponents is because 5 is equal to 3 plus 2, and 7 here is equal to 3 plus 4. So 48 times a to the 5th times b to the 7th is the answer. Next, we have the following expression, which is 3x to the 3/2 power times y cubed over x squared times y to the negative 1/2, all to the negative 2 power. So, firstly, we can cancel some of these powers because we have a numerator and a denominator. So, this is equal to 3. Well, anything in the denominator can be put into the numerator as long as we make the exponent a negative. Or if it's a negative, make it a positive. So here, we just write the numerator again, which is 3 times x to the 3 halves times y cubed. Let me write that better. X to the 3 halves times y cubed times x squared. Well, it's in the denominator, so we make it a negative. So times x to the negative 2. And then times y. Well, in the denominator, it's y to the negative 1/2. So to bring it into the numerator, we just make it a negative of that. So it would be positive 1/2. So y to the positive 1/2. All to the negative 2 power. Then we can simplify this a little bit because some of these, so we have 2 x's here and 2 y's. So what we can do is we can write this as, well, this is equal to 3 times x to the 3 over 2 minus 2. So that whole thing is the exponent times y to the 3 plus 1/2. And this is all being raised to the negative 2 power. Well, here we know 3 over 2 minus 2 is the same thing as 3 over 2 minus 4 over 2, because 4 over 2 simplifies to just 2. And then because these fractions have the same denominator, we can combine them and then just subtract the numerators. So that would mean this is equal to negative 1/2. And similarly, here, 3 plus 1/2 is equal to 6 over 2 plus 1/2, because 6 over 2 simplifies to 3. And then these have the same denominator, so this becomes 7 over 2. And it's 7 because it's 6 plus 1. So we can simplify this even further to 3 times x to the minus 1/2 times y to the 7 halves, all raised to the negative 2 power. Then, as we had above, you can turn this into 3 times x to the negative 1/2 times y to the 7 halves to the 2nd power, and then raise that whole thing to the negative 1 power. And when we're multiplying the 2 in, well, both of these exponents here are to the 1/2 power. So when we multiply the 2 in, it becomes rather simple. So firstly, we get 3 to the 2nd power from the exponent here. So I can point it out, this one here. And then it's 3 squared times x to the negative 1 times y to the 7th. So we just notice that these 2's here and here, so here and here, are taken away by the exponent 2. So this whole thing is then raised to the negative 1 power. Well, 3 squared is 9, so this is written as, well, I guess what I'm saying is this is 9, and then we just take the reciprocal of everything. So x to the negative 1 becomes x to the 1, or just x. Y to the 7 becomes y to the negative 7. And 9 becomes 1 over 9. So at the end of the day, this complicated mess here becomes simply x over 9 times y to the 7th power. And that's 9 times y to the 7th power. Okay, next, you should be able to expand and simplify expressions. So for example, given the following expression, 3 times x plus 6 plus 4 times 2x minus 5, you should be able to say that this is equal to, well, firstly, you expand out 3 into both x and 6. So that becomes 3x plus 3 times 6. And similarly for the second term here, so it's plus, so I'll put this first one in parentheses, plus 4 times 2x minus 4 times 5. Then this becomes 3x plus, well, 6 times 3 is 18, plus 4 times 2, that's 8, so plus 8x minus 4 times 5, which is 20, so minus 20. Then the terms with x's we can combine, and the terms without x's we can combine. So the terms with x's is 3x plus 8x, so that becomes 11x. And then we have 18 minus 20, which is negative 2. So it would be 11x minus 2. Next, given the expression x plus 3 times 4x minus 5, you should be able to say, well, firstly, you do x times 4x plus x times negative 5. And then you add that to 3 times 4x, and add that to 3 times negative 5. Or, all written out, you have 4x times x plus x times negative 5 plus 3 times 4x plus 3 times negative 5. And this becomes 4 times x squared, and it's x squared because you have two x's multiplying each other, plus x times negative 5. Well, that becomes negative 5x, so we can turn the plus into a minus here. So it's minus 5x plus 3 times 4, which is 12, times x. And then it's plus 3 times negative 5. 3 times 5 is 15. And then the negative here means that this would be a minus 15. Then we can combine the middle two terms here such that 12 minus 5 is simplified to 7. So we can write 4x squared plus 7x minus 15. So that is what this is expanded into. Next, given square root a plus square root b times square root a minus square root b, we can expand this out as we did above. So we get negative a times square root a times square root a minus square root a times square root b plus square root b times square root a minus square root b times square root b. Well, these terms are the same in value, but they have opposite signs, so they cancel out. And then the square root of a times the square root of a is just a. So we get a minus b. Next, we wish to expand the 2x plus 3 squared. Well, whenever there's a square here, we expand it out. So we have 2x plus 3 times 2x plus 3. And then we proceed as before. So it would be 4x squared. And that's because it's 2x times 2x plus 2x times 3 plus 3 times 2x plus 9. And it's 9 because it's 3 times 3. Then this is equal to 4x squared plus 6x plus 6x plus 9. And then the two 6x's here can be combined into 12x. So at the end of the day, this is 4x squared plus 12x plus 9. And finally, given the expression x plus 2 cubed, we wish to expand. And so we write this out as x plus 2 times x plus 2 times x plus 2. Well, we start one at a time. So let's keep the first x plus 2 intact, then multiply out the second and third. Well, that would become x squared plus 4x plus 4. Then, expanding this out, we would get x cubed plus 4x squared plus 4x plus 2x squared plus 8x plus 8. And again, that just comes term by term by term, being multiplied together and added to one another. And then, simplifying this expression, we keep x cubed as it is, combine the two x squared terms, so that becomes 6x squared, because it's 4 plus 2. Then we have 4x plus 8x, so that becomes 12x plus 8. Next, you may need to know how to factor expressions, which is the opposite of expanding them. For example, given 4x squared minus 25, we expand as follows. We say that, well, there's no x term in the middle. There's a missing x term, but there's an x squared term and a term with no x. So that means whatever's being multiplied together, there's opposite signs. So there's a plus here and a minus here. Okay. Next, the coefficients that go in here and in here have to be the same in order for there to be no x term. And because 4 is a square number, and so too is 25, we easily see that this is 2x plus 5 times 2x minus 5. So you notice that this number is just the square root of 25, and this number and this number are both the square root of 25, and then this and this, well, they are both given by the square root of 4x squared. And if you expand this out, you will find, indeed, we get 4x squared minus 25. Next, suppose we wish to factor 2x squared plus 5x minus 12. Well, we're factoring this out, and there should be two terms, two factors, and because this is a minus, we know that one of them should be a plus and the other should be a minus. Moreover, we look at the factors of 12 such that when they are added or subtracted, they become 5. One such example is given by, what we want to begin with, so we want to put 2x here and x here. Then what we would get is, well, firstly I messed up here. This would be a minus and this should be a plus. And then this is a 4 and this is a 3. There we go. That factors out. Because, well, firstly, these terms multiply together and we get the x squared term, 2x squared. Secondly, these two terms, negative 3 and 4, multiply together to give us negative 12. Then the cross terms, and by cross terms here I mean 2x times 4 plus negative 3 times x. They add up to give us 8x minus 3x, or 5x, which is exactly the x term here. Then we next look at x to the 4th plus 27x. No, that's not right. I was looking at the wrong problem. What instead we want to look at is, for example, 3x to the 3/2 minus 9x to the 1/2 plus 6x to the negative 1/2. Well, we can factor out, firstly, a 3 and an x to the negative 1/2. What we're left with is x squared minus 3x plus 2. And this, in parentheses, can further be simplified or factored into x minus 2 times x minus 1. So this would be the final expression here. Okay. Okay, and next, what we wish to do is, that was 4, so now 5, what we wish to do is simplify again, but this time in regards to rational expressions. So what I mean by that, for example, is you should be able to simplify the expression x squared plus 3x plus 2 over x squared minus x minus 2. So how do you divide these? Well, there's, of course, long-term polynomial division, or you can factor these two as we did above and see where you get. So let's try the latter. Here, the numerator becomes x plus 2 times x plus 1. And the denominator is x minus 2 times x plus 1. Well, we notice right away that we can cancel x plus 1 on top and x plus 1 on the bottom, which leaves us with x plus 2 over x minus 2. Similarly, you should be able to simplify the expression x squared over x squared minus 4 minus x plus 1 over x plus 2. Well, we can simplify the first term in the denominator. We can factor the denominator in the first term, such that the first term is x squared over x plus 2 times x minus 2. Let me make this a little nicer. And then as before, in the second term, we have x plus 1 over x plus 2. To make the denominators the same, we multiply the second term by x minus 2 over x minus 2, because this fraction here in total is equal to 1, so it doesn't change our expression at all. But what it does is it gives us the ability to write x squared minus x plus 1 times x minus 2 over x plus 2 times x minus 2, because they both have the same denominator now. Both of these terms have the same denominator. Then we expand out so that this becomes equal to x squared minus, well, we expand out the second term in the numerator. That becomes minus, well, in total it's minus x squared minus x minus 2 over x plus 2 times x minus 2. And then this is equal, we can cancel the x squared, and then these two minuses go away because of this minus out here. So this becomes x plus 2 over x plus 2 times x minus 2. The x plus 2 on top cancels with the x plus 2 in the denominator. And finally, this becomes 1 over x minus 2. And finally, you should be able to solve certain equations using the quadratic formula. So, number 6, you should be able to solve. So, for example, given the equation x squared minus x minus 12 is equal to 0, you can utilize the quadratic formula, which, as a reminder, is negative b plus or minus the square root of b squared minus 4ac all over 2a for an equation given by ax squared plus bx plus c is equal to 0. So for our case, the solutions x are equal to, well, negative b here would be 1 plus or minus the square root of negative 1 squared, so 1 minus 4 times 1, because a here is 1, times negative 12, all over 2, because again, a is equal to 1. Well, these two minuses combine to become a positive. So this is 1 plus or minus the square root of 1 plus 24 over 2. 1 plus 24 is 25. The square root of 25 is 5. So this is 1 plus or minus 5 over 2. So the solutions here are x is equal to 1 plus 5 over 2, which is equal to 6 over 2, or 3, or x is equal to 1 minus 5 over 2, which is equal to negative 4 over 2, which is equal to negative 2. So the solutions are 3 and negative 2. As another example, this time without using the quadratic formula, you should be able to solve the equation x plus 5 is equal to 14 minus 1 over 2 times x, as an example. Well, what we want to do is we want to get all of the x's on the same side. So let's add this negative 1/2 times x onto the left side. So this becomes 3 over 2 times x plus 5 is equal to 14. We then subtract the 5, so 14 minus 5 is 9. So then we get that 3 over 2 times x is equal to 9. We can then multiply both sides by 2 to get that 3x is equal to 18, which is 2 times 9. Then we divide by 3, so that x is equal to 6. And that is the solution to this equation above. And that is a rough outline of the algebra necessary in order to advance in this video series. If you found at all that some of these topics were new to you or you need refreshing, feel free to leave a comment and let me know. I would be more than willing to post an individual series discussing all of these topics if that were popular. But in the meantime, we can move on to the next topic, which would be analytic geometry. And perhaps given the time, actually, that can be suited for another video. So, thank you all for watching, and if you want to continue the diagnostic test, please look to the next video on analytic geometry.